Hello, everyone. This is Sadhana Alangar, HL7's Director of Education. Welcome to this pre-recorded presentation on efforts to internationalize a FHIR implementation guide in Japan. The speaker, Hisashi Osanai, is here with us at Cleveland, Ohio. He will be taking up questions towards the end. Remote attendees, please post your questions in the FHIR question and answer box. At this time, please go ahead and start the presentation. Thank you.
Let's start. Thank you for participating in this session. Today, I'll talk about our efforts to internationalize a FHIR implementation guide in Japan. I'm Hisashi Osanai. I'm engaged in the development of health data utilization services at Fujitsu and also a member of JP Core development in Nexus workshop. About Fujitsu, the share of Fujitsu's EMR is 33% for all hospitals and 58% for university hospitals. According to the data of 2021, Fujitsu is EMR share number 1 in Japan. What Fujitsu can do for a world where you can maximize the life experience of everyone and continue to expand the possibilities of the individual. Fujitsu want to nurse this activity with you and make it sustainable. To contribute to achieving the world, Fujitsu is aiming to realize services leveraging health data globally. About National Cancer Center Hospital East, Fujitsu cooperate with the hospital to create IGs and a platform to convert EMR data into FHIR based on actual EMR data in the hospital. NCCHE is leading innovation in next generation healthcare. NCCHE and Fujitsu are working together to create new services for drug development and clinical trials based on real-world data. Here, I'll explain about the EMR data interoperability problem in Japan. As you can see from the figure, different identifiers and names are used for same medication in different hospitals. The background was Japanese EMRs were developed based on the requirement of medical institution by each vendor. They developed with the aim of improving the efficiency of operations without thinking of data utilization. This is because the code, identifiers, and names became widespread without being standardized. As a result, each hospital uses different identifiers and names, which makes integration difficult. In response to the problem, Japanese government is promoting the adoption of FHIR among stakeholders. I have 3 topics here. The first topic is Nexus workshop was established in July 2019 and JP Core IG draft version 1 was released in November 2021. The second topic is a national research project published 4 IGs, and the IGs were accepted as Japanese national standard in March 2022. The third topic is government support for the introduction of FHIR compliant EMR that conform to standard. I'll explain about our approach for data globalization and standardization. The big idea is standardize data of medical institution in Japan and then globalize it. It would be nice if all the data in the EMR could be converted to FHIR at once, but the target EMR data should be clarified after considering the JP Core status and business feasibility. To expand target data, we have to repeat these steps. Now, let's talk about each of the steps. Here, I'll explain about identification of required data. We had interviews with several major pharmaceutical companies as potential data users on clinical trials use case. In the clinical trial use case, pharmaceutical companies want to quantify differences in drug response between clinical trials and EMR data, confirm availability, number, and quality of the data before moving to trials. Then we clarified common data items to each pharmaceutical company per the use cases. After that, we narrowed down the data items considering the difficulty of extraction from EMR. The point here is achieving 100% coverage is ideal, but there is data that doesn't exist in EMR. So we decided 80% coverage is okay. The target data includes patient data, observation data, clinical data, and medication data. Most recently, data on appointments added to target as workflow data. Here, I'll explain about details within each category of the target data. Medication data covers prescription, medication, and injection information. Observation data deal with observed results such as laboratory tests and vital signs. Clinical data covers diagnosis such as disease name and treatment, surgery, and radiotherapy. Patient data deal with individual information such as gender and age, as well as relationship with medical institutions such as inpatient and outpatient. Here, I'll explain about improvement of Japanese IG usability. The Healthy Living IG is subordinate to JP Core because it deals with data from Japanese EMR. Here, I'll show the patterns and idea of creating profiles in Healthy Living. First pattern is profiles inherited from JP Core. Inherit JP Core profiles as far as Healthy Living uses and create profiles one-to-one with JP Core. Second pattern is profiles that inherit the resources from the FHIR standard. Inherit FHIR resources if no profiles is defined in JP Core. Third pattern is profiles defined as profiles to be compliant with the FHIR standard. Inherit the FHIR standard and add the JP Core code systems. Last pattern is profile should not be included in Healthy Living IG. Create other IGs for the use cases and inherit the profiles from the Healthy Living IG. In Healthy Living IG, we have devised 2 points for cardinality in order to improve user convenience. We are an EMR vendor. We can take these approaches because we can guarantee the data existence. The first point is the mandatory item value. The mean of cardinality is set to 1. For example, system, code, and display are mandatory for use as a search item. The second point is removing elements that never have a value. The max of the cardinality is set to 0. As the result, we can only see the available element in snapshot tab in the IG. Here, I'll explain about code system unification. Here is code system correspondence table between Healthy Living IG and JP Core. When there are possible to select multiple code systems by slicing, we decided to narrow down to one code system for usability improvement. In drug case, we have several code systems such as Hot7, Hot9, Hot13, and YJ code, but we decided to use Hot9 only. Here, I'll explain about code conversion. As I explained before, in Japan, each medical institution uses different identifiers and names. We convert code system across medical institutions in order to realize data utilization. We convert code with the FHIR conversion framework. An orchestrator consists of resource generation, data processing, and delivery. Here, I'll focus on resource generation and data processing. The resource generation converts the structure of the EMR to FHIR resources, but doesn't convert the data values, so the different identifiers and names remain. The data processing converts different identifiers and names into standardized one based on the mapping table. The key point here is creating the mapping table. In the case of NCCHE, we could create the mapping table about 20% automatically, but we have to create 78% manually with specialists. 2% is not possible to map. Here, I'll explain about IG in Japanese and English. In Healthy Living IG, we have devised 2 points. The first point is data structure explanation section, such as definition and short elements written in both English and Japanese, because they cannot be switched between the languages within IG publisher function. The second point is switching language from the menu for the document, which are written in Markdown format. Here, I'll explain about code matching. We have 3 situations for code matching. The first situation is code systems are different between Japan and US. In this situation, we define a slicing of the code elements in the profile to use both the Japanese and the US code system. The second situation is Japanese code values are fixed on the profile. Some profiles have fixed code values. For example, vital sign has a fixed test code value in the profile. In this situation, we define the Japanese and US code system respectively and define fixed code corresponding to the code systems. Last situation is Japanese code and US code are difficult to map. For example, drugs sold in Japan and the US are different, so some drugs cannot be mapped. In this situation, an English translation is added to the extension of the Japanese code system in order to support manual mapping. Here is an example of code system support. Code of this profile, which represents type of inspection, is defined as a sliced list of codings to be compatible with JLAC10 and ROINC. Here's an example of code value support. Code values for this profile are defined as 2 fixed values, which represent body height in ROINC and the code systems defined in JP Core, respectively. Here is an example of code name support. The display element of the code system contains Japanese medication name and add English medication name to the extension in order to support manual mapping. Summary. Key point to promote the global utilization of Japanese medical data. Handle more global use cases and clarify the data you need. Labor saving for code matching. I would like to discuss with everyone here, FHIR DevDays, about the point on promoting the utilization of Japanese medical data in worldwide. Here is my contact information. Please feel free to contact me.
Thank you very much. I don't see any questions online. Questions from, thank you.
Thank you so much. It's wow. I didn't realize how complicated it would be. This is complex. And so what an amazing job you all have done on this. On medications, so the Japanese code system for medications is totally completely different than global or
Yes,
United
so-
States or something. And so, yeah, I just wanted to hear more about that because that's like an important part.
So, in Japan, we have a different code system for medication. So we have to map the code from Japanese one to United States one. Yeah.
Sorry, I'm going to follow up with that. I mean, using the Hot9 code system, obviously it was created in Japan, and that's understandable. Is there something inherently different about the way Hot9 is organized that makes mapping directly to SNOMED or LOINC impossible, or is it, or RX norm, if you're going to use the American medication system?
Actually, Fujitsu does not have a knowledge for SNOMED CT or some other code system in here. But we don't have a knowledge, but some pharmaceutical company has to do that. But for only medication which are used for a dedicated clinical trial, so only few medication they can map by manually.
Okay.
It's a current situation.
Okay. And just to follow up, because when you started, you said each provider organization, each hospital or whatnot had their own code systems. Was the mapping done as across organizations, or was each hospital or other medical organization required to do their own mapping to Hot9 or whichever, was appropriate?
Now our approach is Fujitsu guarantee to map Hot9. So for each hospital.
So it was all done by Fujitsu.
Yes.
Mapping.
But so now we just tried one hospital yet.
Oh, okay.
But we have a big share, but we just tried one.
Okay, so lots of more hospitals with lots of more code systems. You're going to have a very busy mapping department for a very long time. Okay.
And it's very tough work. So maybe we might need government support for doing that.
Yeah, and lots of it. Yeah. Okay.
Any other questions? I don't see any questions online. Any other questions from the room? Okay. With that, we are almost out of time. We just have one more minute. Thanks everyone for joining us. Thank you so much, Hisashi, for this excellent presentation.
Thank you for attending.